Alright, first of all, graph that sucker. Then we can prove it's a parallelogram. How? If any one of these things is true, then it's a parallelogram. Alright, so if we show that opposite sides are congruent, then that's this one. Then it'll be a parallelogram. If opposite sides are congruent, then it's a parallelogram. So we can show the opposites are congruent by using the distance formula, but we'd have to do it 1, 2, 3, 4 times. We could also show that opposite sides are parallel. Look at the definition. If opposite sides are parallel, then it's a parallelogram, and that would do what they asked us to do. So we'd have to show that these two sides have the same slope, but also that these two sides have the same slope. We'd have to use the slope formula 4 times. Another way we could show that it's a parallelogram is if we show that the diagonals bisect each other. Right. And how do you do that? We'd use the midpoint formula. We'd find the midpoint of this diagonal and this one, and if they were the same, then they bisected each other, and that would prove it was a parallelogram. So if you show opposite sides are parallel, then the top and bottom slopes are the same, and the left side and right side's slopes are the same. That would prove that the quadrilateral was a parallelogram. Done. But you may have chosen to instead show that opposite sides were congruent. That will also prove that it's a parallelogram. Using the distance formula, the top and bottom side are the same, the square root of 104, and the left and right side's lengths are the same, at root 37. Finally, the least amount of work, because instead of 4 formulas, you only need 2, is to show that the diagonals have the same midpoints. Now the diagonals are these other segments, HD and BF. So if we find the halfway point of the pink segment, BF, and if we find the halfway point of the blue segment, segment HD, if they're exactly the same, then they're cutting each other, intersecting each other right after their midpoints, which means they would bisect each other. And remember, if you've got a quadrilateral where the diagonals bisect each other, then it's a parallelogram, because this works in both directions. But only any one of these has to be true, and that will prove it's a parallelogram. And using the midpoint formula, the midpoint of those diagonals are both the same, which means they bisect each other. So this was a third way to prove that this quadrilateral was a parallelogram. You only needed to use any one of these ways. So I hope that those made sense.